Thanks for coming back. Today, we're going to go over something a bit more interesting, I hope. And what is that? It's how to create our own dynamically configured module, which will give us access to a Redis client within our application. In the last tutorial, we learned about creating a service for managing application logic for creating and joining a poll as outlined in this little center box here. We also went over how to inject this service into our polls controller, or better said, into our polls module, which is sort of outlined. Well, I didn't outline it in this diagram, but it does exist. And that gives us the ability to call PollsService methods from within our polls controller. Soon, we'll start working on this polls repository, which will contain methods for storing data about a poll inside of Redis. But first, we need to be able to access Redis. That's exactly what we'll be working on today. Do remember that, as always, you can go to the Ranker course and follow the instructions to de-git or even clone the repository with this command and the name of the branch you want to start from. Today's lecture or tutorial is tutorial 4. So if you want to start where we are, you would go and get the branch for 03 PollsService. So you would clone or de-git that branch, and you'll be up to date with the starting material for today. Recall that a module in NestJS is the recommended way to organize an application's feature. For example, we're creating a polls feature and therefore have created a polls module, which is in our source polls folder. We see that this module is decorated, or it's a class with a module decorator that does things like imports another module called the config module in this case, as well as controllers and providers, which we've worked on in the last couple tutorials. There's another field, however, which we're not including here, which is the exports field. And this sort of defines services or clients that we'll want to provide via a module to other modules for consumption. And in the example of config module, this will provide us with a configuration service that will allow us to access environment variables or fields in a configuration file, whether that's a JavaScript config or JSON or YAML, or in our case, the .env file. Let's go ahead and remove this. What we want to do today is find a way to create a module that exports some feature based on configuration. In our case, this configuration will be for how to connect to Redis. If we go and look at our app module.ts, we see that we have a sort of factory method on the config module called forRoot. This is how the module is instantiated and ends up loading those environment variables, which in our case are defined in the .m file. In the case of Redis, we will want to make sure that we connect to Redis before our Redis client is available to whatever module consumes it, which in our case will be the polls module. This is a little different from the synchronous forRoot method of the config module. We'll also want to access the previously instantiated config module here inside of our Redis module. A good example of this can be found inside of NestJS's JWT module. I've opened this JWT module, which has a great example of how you can instantiate a module for like storing or reading or parsing JSON web tokens. And the approach that they use, which I'll actually use this second one, this is what we're going to mimic, is to asynchronously register a module. In this case, they import the config module, and then they inject the config service, which is made available by the config module. And by injecting this config service, you have access to it in a use factory. So this inject and use factory keywords are very important when creating asynchronous modules in Nest. You can inject the service, which will provide it as a parameter to this factory method. Then you can sort of configure it by returning. Notice that this method is returning directly an object with your secret for hashing your JSON web tokens. In our case, we will accept configuration parameters for the port and the host of our Redis database, and then we'll sort of instantiate the Redis database in here. But we actually need to define this registerAsync method, whereas the JWT module already provides it for us. And that's what we're going to be doing next. Okay, so we're back inside of VS Code where we'll get going creating our Redis module. And I just want to warn you that what we're going to do may seem a little abstract at first, but hopefully once we actually instantiate our module, it will become clear exactly what's going on. So let's create it inside of the root of the source folder. So I'll new file and let's do a new file and we'll call it redis.module.ts. And the first thing we'll do is kind of scaffold out the structure of what the module will look like. All right, so I've pasted some code into this file. And the first thing you'll notice is that we have a class named Redis Module and that it's decorated with our module decorator. We also have a function, or maybe you could call it a factory or an instance method, to instantiate a Redis module. And this registerAsync function, which is similar or analogous to the one we just saw in JWT, or in other words, this JWT module, you can see that they call a static factory method, if you will, called registerAsync. And we're going to do that similarly. And this will return a promise, since it's an async function, of a dynamic module, which is a type provided by NestJS, which basically needs to return your imports, your providers, and your exports as you might define typically inside of a module decorator. Now notice that for the actual module field of this object, we're kind of returning self here, this Redis module. And if I didn't already mention, we are importing this IORedis, which is the Redis client that we'll be using and is installed in the package.json. Let's save this file. And the next thing I want to do is define some configuration options for this module in a similar way to the JWT module we looked at. In order to do this, I will first define the types that we're expecting. First thing that we'll define are these Redis module options, and these are fields that will be returned by a use factory. And let's go back to Chrome to see that. And so what I mean is that is the return type of this function use factory that we'll have. So in this case, it's returning a secret, but if we come back to VS Code, in our case, it's going to return both Redis options and this callback function, which is optional with this question mark, that will receive the Redis client we're going to create. And this is just a function that returns void. Now, this is just one parameter that we're going to pass into registerAsync here. Let's define the full object of what we'll be passing. We will call this type the Redis async module options. It will take a use factory, and this is analogous again in JWT, in the JWT module to this use factory. And then we want to define this inject property or field and these imports. Now, these are already defined in types that exist inside of NestJS, and we can use TypeScript's pick type to pick the type of another type, or just like an individual field of that type. And I'll show you how that's done. Back in VS Code, we can pick off of the module metadata type the imports field. And so let's actually import that, update the import from NestJS and from the factory provider. So I just had to do some digging around, but that is where these are defined, the types for the inject field and the imports. And so you can see I just use this ampersand to sort of merge the use factory property with the imports and the inject. So let's save this file, and now we're ready to actually define this registerAsync. To define this registerAsync, I'm going to destructure some of the properties from this Redis async module options as follows. Let's scroll a little so we can see it. And here we go. It's going to take the destructured properties from this, which are use factory, imports, and inject, which are these two picked properties. Next, as far as this imports goes, we're just going to forward that on to the dynamically created module. And so I can just get rid of this array, and this imports is shorthand for imports:imports. And then the next thing we'll do is define the dynamically created provider that will be part of the module's providers and an exported feature as well. Part of doing that is to define a string constant that represents the provider so that we can access it by name. And this is one way that you can create a provider in NestJS. So let's add this maybe above the Redis module options. And we'll just call this IORedis key. Maybe you could make it all caps and do underscores. I don't care how you want to do it, but I'll call it this way. Next, inside of the function body, which is a little tricky how this is formatted, but after this opening brace, let's go ahead and add the definition of the Redis provider. Now, this Redis provider is going to return some feature that will be accessible to our polls module eventually. So let's paste this. So the Redis provider is going to have a provide field, which is that key we just created up above. And then it's going to have its own use factory method. Now, this is confusing because we're passing a use factory, but this use factory is the one that we're calling and awaiting with just some generic arguments. Now, notice up here, this use factory can take any arguments as long as it returns some object that has connection options and an on-client ready. We don't care what the arguments of the calling function are, and we'll see how we call this later. That said, the actual provider that we'll be providing to other services or other modules, I should say, has its own use factory. And this is the use factory that really needs to be async. And it's going to basically call the use factory that's passed to it, which we know returns an on-client ready and returns connection options. And then we're going to take those connection options and pass them to IORedis. And so we'll await the creation of this to make sure the client is ready. And then when the client is ready, we pass that client to the callback. And remember, that callback is also part of the response of this use factory or the return value. So we have an on client ready right here. And then we return the actual client. And then we forward the injected value or class, whatever it may be, via the inject field. Again, this may be a little abstract, but when we actually call this use factory or this one in registerAsync, I think it will become clear. Finally, we need to return this Redis module right here. Sorry, Redis provider in the providers and the exports. At the end of the day, we're going to want to sort of call this registerAsync in the polls module imports here. However, that will make this code kind of long, so I'm going to create a file called modules.config.ts at the source folder. So we'll call this modules, I think I call it modules plural, .config.ts. The first thing we'll do is import some necessary node modules for this. The first is the logger, which is provided by a common NestJS package. And that's just to log that our Redis has been connected to. And then we'll also import the config module and service from NestJS, which we've already used, and the Redis module, which is the one we just created. And so we're going to instantiate a little version of the Redis module by calling registerAsync of the capital letter Redis module. So let's scroll up and see all this code I copied really fast. So we're calling the registerAsync method on the Redis module we just created. This is going to import the config module, and then it's going to inject the config service. And if I save this, that's just going to add a space. And by injecting the config service, we're going to get access to it in the use factory. Now, this is just a known pattern for these use factory type providers in NestJS that give us the ability to inject a service or some other module and then use it inside of the use factory. So that's how we get access to this config service. We're then going to create a version of the logger called Redis Module. So then we know that anything logged in this file will be prefixed with Redis Module. And then we're going to return the values or the fields that are required by the use factory. If we go back to Redis Module, remember that this use factory must return Redis Module options, or a promise of Redis Module options, which have connection options, which are defined by IORedis, and an on-client ready callback. Let's go back. So our connection options are just very simple. It will have a host and a port, and that's really a minimal configuration for Redis. Maybe you'd need a password or some other fields for advanced configuration. But we will get these from the config service which we injected and call get Redis host and Redis port. Now, if you recall, we set up a .env file at the root of the project. Let's open that up. And you can see that we already defined Redis host as the local host and the port on 6379, which is the default Redis port. And this Redis is created, just to recall, inside of the root folder, inside of docker-compose.yaml, where we set up this service called Redis using the Redis JSON image. Okay, sorry for that divergent, but I hope that makes sense. And then we also return the callback, which will, when it's invoked, have access to the actual IORedis client. You can see that type there. And we're basically just going to log that the Redis client is ready. If any errors ever come through on the client at any moment, the IORedis has a client.on method that will pass the error in, and then we can just log it. And then it also has a connect callback that we can use to just log and say, hey, we're connected to the options.host and the options.port. Now, this is coming from the actual client notice and not my own config. So it's kind of a verification that it was actually set up correctly. So I hope this makes a little more sense. Let's just go back one more time to the Redis module right here. And you can see that we're kind of calling that initial use factory that returns those options and on client ready. If we go back, you see that that's what's returned here. And then if I go back to Redis module, these are getting in the way, sorry. Let's go back to Redis module. And you can see that then we invoke the client with those connection options and call the on client ready with this client. But where's on client ready coming from? It is coming from this calling function. So we're basically executing all of this code. I almost dragged it inside of here. Furthermore, just one more thing I want to mention is that we're going to inject this injected service. And if we go back to modules, that injected service is the config service. Now you may say, why are we like injecting it twice? And the reason is that inside of the polls repository layer that we're going to create later, we're also going to want to access an environment variable, which happens to be, if I open up .env, the poll duration, which is sort of meaning we want our poll to live for 7,200 seconds or 2 hours. Okay, we're about ready to actually fire up our application and see some of the logs in module.config, see some of these logs that get run when the client is ready. First, we need to put this module inside of our polls module, which is here. It's in the polls folder. If you need to relocate it, here's the polls module, and we'll just import that Redis module and auto import it and save. Now remember, we had that Docker file that loads the Redis, and then at the top level package JSON, because we have a package JSON inside of this server folder as well. Let's collapse some stuff. So not this package JSON, but the top level one. We have this start script, which kind of runs Docker Compose, our server and our client all at once, even though we're not really doing anything with the client. But let's run npm run start and make sure you have Docker or Docker desktop running on your computer so that it can fire up the Docker Compose containers in this Docker Compose file. So let's start this. Maybe make this a little taller. And you can see some of these logs, which are a little big because I increased the font size. But you'll see, for example, that the Redis client is ready here. And you see that it has this namespace in brackets that we named Redis Module. And it will also show that we've properly connected to it on localhost 6379. Well, folks, now we have the ability to connect to Redis and we'll be able to store data in it with that IORedis client. And that's what we'll be working on next time, creating a polls repository, which will have access to this client and can store and retrieve entities from Redis. What that means is we'll actually be able to send an HTTP request. It will hit our controller. Our controller will call our service, and our service will call our polls repository to insert a new game into Redis. Hope to see you then. Take care. Hasta entonces, que se cuiden.